So your task is, you have this circuit, R, L. Your task is to convert this one to x dot equal to ax plus bu, y equal to cx plus du. That's all. This is your task. This, what we call this one? State space. Okay. Do you know, you can see there is a x. There is x dot, is it? What is the meaning of x and x dot? Okay. The x dot actually is coming from dx over dt. Okay. X dot actually refer to, let's say we have a timeline. Timeline, This is current time or future time or history? Current time. So let's say if you want to know what is the future in mathematics, what you do?
Differentiate.
You differentiate something, is it?
Yes.
In mathematics, xt actually refer to the current. Okay, in mathematics. In mathematics also, if you want to predict the future value, you need to in mathematics. Okay. Let's say if you want to know history, what you need to do? Yes, you need to integrate. If you want to know the history value in mathematics, past value. Okay. So this is mathematics lah. If you look at this one, xx is the current value, is it? If you have the current value, can you predict the future value? By using the equation? Yes. So it means that the advantage of the state space, when you only have the current value, you can predict the future value. What will be happen? You can predict it. Okay? And also by using the current value also, you can know what is the output. Is it clear? Okay, so this is the advantage of the state space. You only have the current value, but what's happened to the future? Kan? Is it the system is stable? Is it the system unstable? Is it the system is good? Is it the system is rubbish? Something like that. So you just plug in the current value here, and then you can know the future value. That's the advantage of the state space. Is it clear? Okay. So this is the meaning of the x dot, x, y. Okay. But now, the question is, an RL circuit shows the voltage as the input. So you just take note all the information. Voltage, input, and then what? What is the output? According to the question, current across the inductor as the output. Output we call IL lah. IL refer to current across inductor lah. And then after that, what is another information? IL at the state variable. So it's also said that IL is a state variable, which is state variable. Okay. Okay, so this is the information we have lah. According to the state space 1, you refer to the input. U is the symbol of the input. Okay. Y is the symbol of output. X is the symbol of state variable. So you must know the meaning of the state space equation. X refer to state variable, U refer to the input, Y refer to the output. Okay. So in this case, we can conclude that the input is U, the output is Y, the state variable is X. So you know that in this case, you know what you need to find. But you know what you need to find. So in this case, since X is, the symbol of X is IL, is it? The symbol of X is IL. Since this X you have dot, is it? So you need to put dot. You just replace lah. Every X you replace with IL. IL, okay? Every U you replace with voltage input, normally we name as a VI. VI. Every U you replace with VI. Every Y you replace with IL. So you just put it like this. A, the X is IL kan? IL dot A, the X is IL plus with B, U equal to VI, then Y equal to IL also, same thing. C, X equal to IL plus with D, U equal to VI. Okay. This is your question. Whatever you do, because this equation is IL dot equal to something, is it? And then the second equation is IL equal to something. Whatever you do, you must to make sure you find the IL dot equation, exactly the IL equation. Is it? That's your target. Because based on the state space, the structure of your state space is IL dot equal to the rest of the question kan. The second equation IL equal to the rest of equation. So there are two equations that you need to find, which is IL dot and IL. So it means that you must do the KVL, the KCL until you get the IL dot equation and IL equation.
So that's one.
Correct. Your friend's answer is correct. This is a first order system. Why first order system? Because you look at the component here. Resistor, is store voltage or current resistor? Resistor, is it store voltage or current? No at all. Because the resistor only let the current through, is it? It will not store any current or voltage. How about the inductor? What is store? The inductor store current. So it means that although you take off the voltage, the current will go in through. Because the function of inductor to store current. So let's say resistor, if you give the power supply and then you take out the power source, there is no current or voltage. But the inductor, if you give the power supply and you take out the power source, the current still there. Okay? How about the capacitor? Store voltage. You give the power source, the capacitor will store voltage. After you take out the power source, there's still voltage inside the capacitor. So it means that in order to know the order of the system, you need to calculate how many components that store voltage or current. So in this case, how many components store voltage or current? One. So that's why it's the first order. So let's say if you have two capacitors, one inductor, and two resistors, what is the order of the system? 3, third order system, because there are two capacitors, one inductor. 1, 2, 2 plus 1, 3. There's a third order. Are you clear with that? Okay. So, why the order is really important? If you know that, if you still remember, A, B, C, and D is a matrix. Matrix, kan? So, since this is the first order, so it means that the dimension of A is 1 by 1. Okay? B also, the dimension is 1 by 1. C, 1 by 1. D, 1 by 1. Okay? So you know that your answer must be 1 by 1. If you calculate, then you get 2 by 2, your answer is wrong. Okay? This is how you want to make sure your answer is correct or not. Is it okay? Okay. Boleh tak?